Hi everyone, so today we are gonna compare between parallel scan and setting a smaller page size for the scan, so per scan in DynamoDB. So let's read this from Find Best Practices. So the answer here is when comparing parallel scans and setting a smaller page size for a scan in DynamoDB, there are several factors to consider. Reducing page size. Reducing the page size can help to mitigate the impact of a scan operations on your database. By default, a scan operation reads an entire page, 1 MB, but you can set a smaller page size using the limit parameter. Okay, so a scan, you can scan the entire page, but you can set a smaller page size using the limit parameter. This reduces the number of read operations required for each scan request, creating a pause between each request. This allows other critical requests to succeed without being throttled. For example, if each item is 4 KB and you set the page size to 40 items, okay, each item is 4 KB and you set the page size to 40 items, a scan request would consume only 20 eventually consistent read operations. Yep, because it's divided 40 times then 4 KB divided by 2. So 40 eventually consistent read operations or 40 strongly consistent read operations. However, this approach may lead to increased latency since more requests are needed to cover the same data. More requests are needed to cover the same data. Yeah, so this is for the strongly consistent read. For strongly consistent read, you have more latency compared to eventually consistent read. Parallel scans. Parallel scans involve logically dividing a table or index into multiple segments, allowing multiple workers to scan the segments concurrently. This can significantly speed up the scan operations, especially for large tables. Scans operation for large tables. However, parallel scans can place a heavy demand on provision throughput. If the table's provision read throughput is not being fully utilized and sequential scan operations are too slow, a parallel scan may be the right choice. However, parallel scans can also cause other applications accessing the table to be throttled if they need to access the table. Alright, so for parallel scans, it can also cause other applications accessing the table to be throttled. Throttled. How do you pronounce that? Throttled. Therefore, it's recommended to monitor your parallel scans to optimize your provision throughput use, while also ensuring that your other operations aren't starved of resources. Conclusion. In conclusion, how do you pronounce that? Reducing the page size can help to manage the impact of scan operations on your database, but it may increase latency. On the other hand, parallel scans can significantly speed up scan operations, but they can also place a heavy demand on provision throughput and potentially throttle other applications. Therefore, the choice between these two options depends on your specific use case and requirements. So if the question is, if a company has a large Amazon DynamoDB table, which they scan periodically so they can analyze several attributes, the scans are consuming a lot of provision throughput. So if it's consuming a lot of provision and throughput, so that is like it's already using a parallel scan. What technique can a developer use to minimize the impact of scan on the table's provision throughput? Um, so it minimize the impact of the scan. Yes, set a um, smaller page size because parallel scan can cause can re- may it will require a lot of provision throughput. Yep, can significantly speed up scan operation. It can speed up because you're doing a parallel scan, but it's also it can also place a heavy demand on provision throughput. You need provision throughput for scanned operations, right? You need to remember that if you're going to do scan operations, you need provision throughput. So to minimize the impact of that scan, you have to set up smaller page size. But can you do both? Can you do both at the same time? So this is what um, what's nice about AI scaling DynamoDB for big data. Yes, you can perform both parallel scans and set a smaller page size of the scan at the same time. Setting a smaller page size, as discussed earlier, you can set a smaller page size for your scan operation using the limit parameter. This reduces the number of read operation required for each scan request, creating a pause between each. Performing, you can also perform blah 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 blah. In this code, we use the multiprocessing module to create a pool of worker processes. Each worker is responsible for scanning a different segment of the table. The page size parameter is passed to the scan method. Set a small page set. Okay, so let's read this scan table. Where is this getting used? Scan table. So they use this one here. Scan table. This is a Python code. I'm not a Python coder, but I can still read this. This is the main, I guess. This is the main. This is just the function. Total segment, page size 20. Where is this? Yeah, it's getting used here to do the scan operation, and this is the result. Do some scan, page size, setting the page size. Page size here is put on the limit. Yep, page size. So this is not about paging, this is just setting the page size for each scan. So page size will be set to the limit, and segments, you put the segments here, total segments, and then I here is a segment. All right. So when doing parallel scan, you can set each scan with page size, so you can limit the number of items per scan. All right, so that's it. Thank you and goodbye. See you in the next video. Bye.